Have you ever stopped and just wondered how on earth a massive airplane, we're talking hundreds of tons of metal, just lifts off the ground and flies? I mean, it really feels like it should be impossible, right? Like magic. But you know what? The real answer is actually brilliantly simple. Seriously, just take a second to picture it. A 200-ton machine just going up. It's something we see all the time, but when you break it down, how does this enormous, heavy thing just defy gravity? What kind of force is strong enough to hoist all that metal, plus all the people and luggage, straight up into the sky? Now, I bet if you think back to your school days, you were probably taught one specific thing. It's all because the top of the wing is curved, right? That the air has to travel a longer path over the top than the bottom? Yeah, that probably rings a bell for a lot of you. Okay, so here's the thing. That explanation, it's not really the whole story. Not even close. The real reason planes fly is actually way more intuitive, something you've probably felt with your own two hands. So let's just cut through the confusion and get to the simple truth. So let's put these two ideas side by side. The common myth, which is all about air particles having to meet up at the back of the wing, it's a complicated idea involving pressure and path length, but honestly, the simple truth is what really matters. A plane flies because it's pushing a massive amount of air down, and because it pushes the air down, the air pushes the plane up. That's it. Action, reaction. And if you want a perfect example of this, just think about sticking your hand out of a moving car window. Come on, you've done this, right? You hold your hand flat, then you tilt it up just a little bit. What happens? Whoosh! You feel this powerful force pushing your hand right up. What you're doing is pushing air down, and the air is pushing your hand up. A giant airplane wing. It's doing the exact same thing, just on a way, way bigger scale. And believe it or not, that's the fundamental physics right there. It's not some super complicated, mysterious aerodynamic principle. It's just good old Newton's third law. For every action, there's an equal and opposite reaction. The action, the wing shoves a bunch of air downwards. The reaction, the air shoves the wing and the whole plane upwards. And that upward shove, well, that's what we call lift. Okay, so the wing's whole job is to push air down. Got it. But how does it do that so well? Well, it's got this kind of brilliant 1-2 punch working for it. The shape of the wing and the angle it's tilted at. So let's look at this 1-2 punch. First up is the shape, what's called an airfoil. That special curve you see on a wing, it's perfectly designed to help guide the airflow downwards. But here's the second part, and this is super important, the angle of attack. And that's really just a fancy way of saying the tilt of the wing. It's exactly like tilting your hand in the car. By tilting the wing upwards into the wind, you are physically forcing that air to go down. And really, neither one of these things works that great on its own. You could get a totally flat board to fly if you tilt it at the right angle. And a curved wing can make some lift, even if it's perfectly flat. But when you combine the smart, efficient shape of the airfoil with the raw power of the angle of attack, that's when you get a system that is just incredibly good at deflecting air and creating tons and tons of lift. But, of course, just creating lift isn't the whole game. To get a plane to actually fly straight and level, everything has to be in this perfect balance. It's like a constant, high-stakes tug of war happening up in the sky. So you've got these four main forces battling it out at all times. You have lift, which is pushing the plane up. Fighting against that is weight, gravity, which is pulling it down. Then you've got thrust from the engines, pushing it forward. And pulling it back is drag, which is basically just air resistance. And how the plane flies really just depends on how these forces balance out. It's pretty simple. When lift equals weight, the plane doesn't go up or down, it just stays at the same altitude. And when thrust equals drag, it's not speeding up or slowing down, it's just cruising at a constant speed. It is a non-stop balancing act, from takeoff to landing. All right, so now that we've got the real secret down, let's circle back and bust some of those myths we all learned and really see why they don't tell the full story. So myth number 1, the air going over the top and bottom has to meet up at the end at the exact same time. Nope, that's just flat out wrong. The air on top actually moves way faster. Myth number 2, the curved shape of the wing is the only thing that matters. Also wrong. Think about it, a stunt plane can fly perfectly fine upside down, and it does that by using its angle of attack. And finally, myth number 3, it's all about the pressure difference. Well, the pressure difference is real, it's there, but it's a result of the air being pushed down. It's not the fundamental cause. The cause is, and always has been, pushing air down. There's this fantastic quote from Wolfgang Langewies's classic flying book, Stick and Rudder, and it just nails it. He says, "The main fact of all heavier than air flight is this. The wing keeps the airplane up by pushing the air down.
I mean, for decades, this is how pilots and engineers have really understood it. It's just the clearest, most direct way to explain what's happening. Okay, we've covered a lot here. We've talked physics, we've busted some myths. So if there is just one thing I want you to remember from all of this, what is it?
It's this. This is the whole secret. An airplane flies by pushing air down. The air pushes back up. That's it. It's not magic. It's not some crazy, complicated formula. It's just action and reaction. Brilliantly and beautifully simple.